Hello everyone, we'll take a look at a group of exponential equations that require the need of the use of logarithms. Our first example is 3 to the power of x equals 21. So the variable in this case is in the exponent, and the equation is kind of simple because it only has two terms, and we can simply solve it by converting this exponential expression into log expression and stating that x is the exponent, or the log we say, with base 3 of 21. Or in other words, using the change of base formula, we can say log of 21 over log of 3. And we'll consider this as the answer, the exact answer, and we'll say that, so that's the exact answer. And if we want to find the approximate answer, we can simply substitute the numbers or type the numbers in the calculator, and we'll get that x is equal to 2.77. Now, always remember to round the answers to 2 decimal places when it comes to logarithmic or exponential logarithmic equations. Okay, now I want to show you another way of solving this equation, and the reason why is because not all of these equations will be this simple. Okay, so not all equations can be solved by simply stating, okay, so the exponent will be equal to that, and then bam, solution. So another method that we use is by taking the log of both sides of the equation. So we take the log of the left side, which is 3 to the power of x, and the log of the right side, which is 21. We haven't broken any rules. We've applied the same operations to both sides of the equation. So according to the power law, this x will become a coefficient. So in other words, we can write here x log 3 equals log 21. And from here, you can isolate x by dividing both sides by log 3. And we get x equals log 21 over log 3. So that's the exact answer. It's the same as the one we just found with the previous method. Now we're going to take a look at the next equation. Now in this equation here, we have 5 to the power of 2x plus 1 equals 6 to the power of x minus 2. So if you think about it, using this method, the method we used in here, to this equation can be slightly awkward because you have variables in both sides of the equation. That's when this method here comes in handy. So we're going to take the log of both sides of this equation. Make this bigger so we focus only one thing. All right. Maybe I can write a little slightly smaller here. Okay. So we'll take the log of the left side. Oops. Sorry about that. So 5 to the power of 2x plus 1. And then we'll take the log of the other side as well. Again, we have done nothing but taking the log of both sides, right? Nothing has changed, right? And in the next step, we apply the exponent law of logs, which means we have 2x plus 1 times log of 5 equals x minus 2 log 6. And now you see that we have a multiplication of a binomial with a monomial, so one on each side. Simply expand. So multiply, multiply. I know that it's an easy operation for us to see, but just because the terms are not just simple numbers, that's why I'm just pointing at them. So 2x log 5 plus log 5 equals x log 6 minus 2 log 6. Next thing we want to do is spot where our variable is. So our variable is x, so it's here and it's here. So our variable goes with these two terms right here. So we'll group these two terms to the left side of the equation and take log 5 to the right side. So that will give us 2x log 5 minus x log 6 equals negative 2 log 6 minus log 5. Again, keep an eye close to your variable, and we're going to factor x out. We have 2 log 5 minus log 6 equals, and I'm going to do something fancy here, not too fancy actually, just kidding. So, but I'm going to take the negative one out. The reason why is because I have two negative terms in here, so we have to apply the quotient law. I'm a bigger fan of the product law than quotient law, so whenever possible, why not convert it? So that would be 2 log 6 plus log 5. And now I want to isolate x, obviously, so I will divide both sides by the coefficient of x. And the coefficient of x is this one here. And we'll divide by 2 log 5 minus log 6, both sides. So simplify. And then we'll have x all by itself here equal. And now we have to do a little bit of work on the right side of this equation. So the minus will stay here. The number 2, which is a coefficient, will become the power of 6. So that will change it to log of 6 squared, which is 36. And then plus log 5. And down here again, we'll do something similar. So the coefficient 2 will come in and we'll make 5 into 5 squared. So log of 25 then, that's what 5 squared equals, minus log of 6. So continue simplifying. Now it's time for us to apply the product law here. So we have log of 36 times 5. And down here we have the quotient law, so log of 25 over 6. So in a simpler form, we can say that x equals negative log of 36 times 5 is 180 divided by log of 25 over 6. You're probably thinking of getting rid of this minus. It could have happened if we took out the negative in here, so that would have changed this to 6 over 25. If you want to do that, that's fine, but if you want to leave it in this form, that's totally fine as well. And I bet some people are probably thinking of, why not write this as a single log? So log with base 25 over 6 of 180. Definitely can do that. Not necessary. So this would be the exact answer. Sorry, I just want to make sure that it will stay nice and warm inside the box here. Okay, it's a triangle. So there we go. Now, if we want to find the approximate answer again, all we have to do is use the calculator. Okay, so we'll move on to the next example. Example 6. In example 6, we have 5 to the x minus 5 to the negative x over 2 equals 3. So again, an exponential equation. What I want to do first is get rid of that denominator. So we have 5 to the power of x minus 5 to the negative x equals positive 6. Remember, you simply multiply by 2 both sides, right? And that will kill that 2 here. All right, then. So the next thing that we're going to do is convert the negative exponent into positive. So 5 to the x, minus 1 over 5 to the x equals 6. And now we're going to eliminate this denominator by multiplying both sides of the equation by the lowest common denominator. And the lowest common denominator is 5 to the power of x. So you multiply here by 5 to the x, multiply by 5 to the x, and multiply by 5 to the x. The equation now will change to become 5 to the power of 2x minus 1. And why not bring this term to the left side? So minus 6 times 5 to the power of x equals 0. I'll bring it in better form here, 5 to the power of x and then squared, minus 6, 5 to the power of x minus 1 equals 0. Now, I would have loved to be able to factor this, but it's not possible because we can't find two numbers that multiply to negative 1 and then add to negative 6. So we're going to go quadratic formula. So we'll say that 5 to the power of x, that's what we're solving for, that's our variable. Okay, so 5 power x would be equal to negative 6, negative b, right? Plus or minus the square root of negative 6 squared minus 4 times coefficient of 5 to the x squared is 1 times c, which is negative 1. Right? I'm just going to highlight the coefficients for now. So the coefficients are 1, negative 6, and negative 1. So these will be our values of a, b, and c, right, for the quadratic formula. And that will be all over 2 times 1. So 5 to the x equals 6 plus or minus. Do some simple calculations here. You get root of 40. And that divided by 2. Some more simplifying here. So we have 6 plus or minus 2 root 10 over 2. Even better, 3 plus minus root of 10. So that's 5 to the power of x. Remember that we need to solve for x. So we're going to say that x equals the exponent or the log with base 5 of 3 plus or minus 10. We'll keep this in bracket because it's a single unit, okay? Now we have to inspect our solutions. So we're going to say, okay, what happens if we have 3 plus root 10 inside the log? Or does x equal to log base 5 of 3 plus root 10 make sense? Well, 3 plus root 10 is evaluatable, so you can use a calculator. It's a positive number right here. Oopsie. So that's a positive number. So that means that we'll give this solution a pass. And x equals log with base 5 of 3 minus root of 10. Okay. This one here. Root of 10 is a number bigger than 3, so that would be a bigger negative. So we're going to say this is a negative number. So we won't let this solution go there. So we're going to say we only have one answer or one solution, which is log with base 5 of 3 plus root of 10.